Good morning, everybody. Now we're going to see about a GATE class, and this was presented by Erode Sengunthar Engineering College under scheme of AICTE PRERANA, a scheme for preparing SC/ST students for higher education. And the session is on the date of 15/10/2020. The time is 2 p.m. to 3 p.m. The subject is communication, and the session in this communication subject we're going to see about amplitude modulation. And this amplitude modulation is going to be taken by the resource person Dr.V.Premchandran, myself, AP ECE, Erode Sengunthar Engineering College. Fine. Okay, in this today's session, communication subject, communication is a vast subject. In the subject, we're going to see about the basic one is amplitude modulation. The communication which mainly deals with the modulation. Modulation is the basic concept. Through the modulation alone, we can transmit a signal and we can communicate with the communication taking place between the transmitter and receiver, the two end users. So what are the topics today we're going to cover? Today we're going to cover about introduction, modulation, what is modulation, amplitude modulation, and some problems based on the amplitude modulation. And now we're going to see about amplitude modulation, and then next we're going to see about definitions. Okay, in this definition we're going to see definition for modulation and why the modulation is required. Fine. First we're going to see about definition of modulation. In the modulation process, some characteristics of high frequency carrier signal, a bandpass signal, is changed according to the instantaneous amplitude of information, a signal, information based on the signal. Fine. Generally, modulation, what does happen? Modulation mainly changes the nature of the signal. Generally, let's take some example. If you throw a paper, if you have a paper in a hand, if you just throw it over, whether the paper will travel for some meters? No. It's some meters or it's some kilometers? No chance at all. Because the paper is lightweighted. It cannot travel that much. If we make the paper as a bundle and if we throw also, since it's lightweight, due to the friction of air, it cannot travel much. It can travel alone for a few feet, it may be 10 feet. So the something is required to carry over the paper to long distance. So what shall we do? Okay, let's take a stone and make a bundle. Okay, wrap the paper over the stone, and now you just throw the stone where the paper has been wrapped. That stone could go at least a kilometer if we throw with a full force. Okay, before we just bundle a paper and throw it over, it only goes to some feet. But if we make a wrap on over the stone, if we throw it over, it can travel nearly a kilometer. How this happen? Because the stone has a weight. It can travel. It can passes over the air friction. So similarly, this is the modulation concept. This is the modulation concept. The paper is the message, but paper alone cannot able to travel. It has a less energy in means of energy. So it requires something to carry over the paper. Here the stone has carry over the paper to the long distance. Similarly, if I'm talking here, if I want to talk to a person which is far away from 10 feet, I can just talk loudly. That is enough. If I want to talk to many people, they were nearly around 100 feet away from me. So what shall I do? I can go with a amplifier. By amplifier, you can see street gathering, uh, uh, big gathering. Some leaders could address the big gathering. There, you can see after a few words around, the people will be stated over there, and the speaker would start speaking. There, they use the what they there they use these amplifiers. With the amplifier, we can amplify the sounds on the what we talk to the mic. It can be amplified and can reach the few distance. Now, I want to talk to a person which is far away. It may be 100 kilometers, 200 kilometers, which I cannot talk. We cannot carry over the speaker. Yes. Now I want to send my voice signal. How I can send? How much I can loudly talking also? It can't travel so much distance. So There I need go for some technology. So that technology is nothing but modulation. I can use the engineering, communication engineering, and I can change over my signal into some other format of signal. By that, I can transmit my signal to long distance. So that is known as modulation. Modulation is faster. So, okay, high frequency signal. Why the high frequency? The what we talked the audio signal is only the frequency of 20 hertz to 20 kilohertz. Yeah, that is not that much. What really it will be in some terms of okay, some hertz, some kilohertz. Fine. And and if it wanted to carry it, and if it wanted to be pass it over a long distance, if it wanted to be a pass it over a long distance, certainly for a long distance, if it want to be pass it over to the a long distance, it should be placed over to the some of the high frequency signal, some of the high frequency signal. Why the high frequency? What is that thing in the high frequency? The high frequency I can explain. E is equal to h nu. It's a Planck constant. E is nothing but energy, where okay E is equal to E is the energy is h nu, where h is the Planck constant and nu is nothing but frequency. So energy is directly proportional to frequency. If the frequency is high, the energy is also high. So if we choose a high frequency signal, the signal can travel for a long distance, for certain kilometers, for so many more kilometers. So I'm going to place my message signal over a high frequency signal and I can pass it over a long distance. The okay, that placing over my message signal, low frequency signal over the message carrier signal, high frequency signal. The process is known as the modulation, and that process is known as the modulation. Okay, why we are going for the modulation? So this is the definition. Once again, I'm going to read the definition. In the modulation process, some characteristics of high frequency carrier signal is changed according to the instantaneous amplitude of the information. Fine. Why modulation? There are for some reasons are given over here. Suitable for signal transmission. For long, yeah, previously I said with a many example, if I want to transmit a signal throughout the long distance, I can for certain kilometers, I shall go with the I shall go with the modulation technique, where my message signal would place it over the high frequency signal and transmit it. And next one, I can transmit many signals through the common channel. I can transmit many signals. So this is one of the greatest advantages for modulation. I can transmit more than two signals. More than two signals. It means n number. Fine. This can be easily operated. This can be easily operated because the frequency component mainly depends upon the inductive device. It can inductive or capacitive device. The frequency calculation can be done either by inductive or capacitive device. And one of the greatest advantages is that the noise has been reduced. The stability of the signal will be raised. So noise rejection is the one of the biggest challenges that, and stability is also is going to be a problem. Fine. Next, we're going to see about modulation. Okay, example broadcasting for both audio video signal. Nowadays, we are seeing some live telecast. Yeah, nowadays we are seeing channels, TV, movies, or live cricket show. This show would happen in somewhere else. Now the IPL session is going on in Dubai, but we can see in our home in Tamil Nadu how we can see this thing because of the communication modulation. That video signal has been converted. And it will be transmitted, converted using modulation process and transmitted to the satellite. And though the satellite will be receiving in a home, and we can see this. So this is what the this is one of the application, and we are nowadays we are using mobile phones. Okay, what is happening? We are talking to a device, and the device through the device the opponent person or the who want to talk, he also having the device, he can hear and talk to us. So this is the another way of communication. So here, what does happen? What we're talking through a device, the device converted into some signals and transmitting over to the tower, and the tower is still transmitting the signal. And finally, we want to, and the signal is reached to the person whom we want to talk. Yeah, this is what the application of modulation. And what are the three types of modulation? Okay, this modulation is classified into three types. Okay, how this modulation has been classified? This modulation is classified into three types. Now you can see. Yeah. One is amplitude modulation, frequency modulation, and phase modulation. Okay, first one, amplitude modulation. A wave has three parameters. What are three parameters? Nothing but the amplitude and frequency and phase. Okay. If you modify the amplitude of the carrier signal, then the modulation is said to be as an amplitude modulation. If we modify the frequency of the message signal, or sorry, carrier signal based upon the message signal, it is known as frequency modulation. If we change the phase of the carrier signal based upon the message signal, it is known as the phase modulation. It is known as the phase modulation. So these are the basic three modulation types. These are with this type only will transmit a message signal to the receiver side. Right. So we have been going to the next slide. Here this is the basic block diagram. This here we can see the source, channel and sink. Source, channel and sink. Here, okay, let's see the message signal first. This is the message signal. If the message signal is modulated and through channel the signal is going to transmit as the modulated signal. Now we can see how the modulated signal will be. Yes, here we can see once again. This is the low frequency signal, and after modulating, the signal is converted as this. Now the signal is converted to high frequency signal. Since this is an amplitude modulation, the amplitude of the signal is changed based upon the message signal, Okay. After we transferring the signal could be received at the receiver side. Now I want the message signal, original message signal, and I want to remove the carrier signal. Carrier signal is the control of the carrier signal is over. Now it should be removed, and I want to get back only the message signal. How we can get it back? Okay, this can be get it back by a demodulation. The demodulation process, which is inverse operation of the modulation. In this process, I'll remove the carrier signal and the message signal alone remains. Here now we're going to see how it has been. Yes, you can see it. Okay, the signal has been transmitted is getting back in the demodulator side. So what the signal is given as input in the modulator is getting back in the demodulator with the same frequency without any changes. So now you can see this baseband signal frequency is FM. It can indicate as FM, and this modulated signal is indicated as a FC carrier frequency. Which frequency is the frequency of the carrier, and finally the demodulated signal is nothing but FM. The modulated signal is FM. Comparatively, here I'm going to compare. Here the voice is going to be some hertz, 100 hertz to some kilohertz, whereas GSM phone could be using the frequency. The GSM mobile phones nowadays we are using GSM mobile phones are there. Many other phones also there, but mostly of the market, the commercial purpose, we are using the GSM cell phones, which work under the frequency of 900 to 1800 megahertz. Fine. The frequency of FC is higher, which is very much higher than frequency of the message signal. So once again, we see look back how it has been developed. Initially, the message signal is given to the modulator. After the modulation, we get back the modulated signal, high frequency modulated signal, and this signal is transmitted and received and demodulated, and now we get back the original signal. Now we get back the original signal. The next we're going to see about the mathematical expression of the amplitude modulation. We have seen the previous slide, we have been seeing about how the modulation would happen. In this slide, we're going to see about how the modulation, what is the mathematical expression, and we're going to see it now. Amplitude modulation of a high carrier signal is varied according to the instantaneous amplitude of the modulating message signal. So, the high frequency signal's amplitude is changed based upon the instantaneous amplitude of message signal MT. So, here in this session, carrier signal represents a cos 2 pi fct or cos omega ct. This one is the angular frequency, this one is the linear frequency, where omega is equal to 2 pi f. This C indicates here the C is a suffix has been used. Why the C has been used? This C has been used to indicate. This C indicates this is a carrier signal. This is a carrier signal. Fine. Message signal. How are we going to represent message signal? This M of t. So M of t, which is nothing but same as cos 2 pi f t, where f suffix m, or we can represent as an angular frequency cos omega m mt. This is the message signal and this is the carrier signal. This after modulating the carrier signal based upon the message signal, finally we get back the AM signal, amplitude modulated signal is indicated as SAM of t, just here AC plus MT, okay, whole bracket cos 2 pi FCT. So this is the final amplitude modulated signals equation. This is the final amplitude modulated signals equation. Okay, everybody kindly note down it. Everybody kindly note down it. Okay, have you noted down? Yeah, let's move on to the okay. Mathematical expressions. Some of the mathematical expressions based upon the AM signal. So here we're going to see about some mathematical expression of the AM signal. Fine. Mathematical expression for AM time domain. This is the time domain signal because we represent all the signals in terms of t. Since we all represent all these signals in terms of t, this signal is said to be as a time domain signal. This signal is said to be as a time domain signal, SAM of t. Fine. 1 plus okay, SAM of t, okay, 1 plus k cos omega mt, where uh, k is the constant cos pi of omega ct. Expanding this procedure, we can expand this above equation. This is nothing but a constraint equation, and this constraint equation can be expanded as I just multiply this cos omega ct here and here, and the equation would be SAM of t cos omega ct plus k into cos omega mt and cos omega ct. So this is how the expanded procedure has been done. Okay, this here we have two things: cos omega ct, cos omega mt. This can be shrunk using the some expansion on some equations, or the trigonometric expansion equations are there. There are many trigonometric expansion equations. Here we can convert it back from cos to some other things. And okay, cos A B has some expansion, and it's indicated here. Cos AB is equal to 1 by 2 cos A minus B plus cos A plus B. So therefore, by applying by applying using this, we can change it over this one as a cos omega ct plus k by 2, since here 1 by 2, k by 2 cos omega A minus B. So A is omega c and B is omega m. So omega c minus omega m into t plus k by 2 cos omega A plus B omega c plus omega by 2. So the total power, if you transmit an AM signal, and here we want to calculate the power of this signal. To analyze the signal, we need power. So A square plus K square by 4 plus K square by 4. So therefore 1 plus K square by 2. So this is the total power consumed by the AM signal. That K is the constant. Okay, from here, we're going to see some basic problems. How we're going to solve the things in the AM amplitude modulation signal. First, we will take the question for an for an AM amplitude modulation for AM amplitude modulation signal. Amplitude of the modulating signal is 0.5 volts. Whenever we represent the amplitude, we would represent in terms of volts alone. The amplitude should be measured in terms of volts, and the carrier amplitude is 1 volt. Find the modulation index. Okay, modulation index is nothing but the message message strength by message signal strength divided by carrier signal strength. Message signal strength is nothing but volt or signal amplitude is nothing but the strength. Okay, amplitude and strength both parameters are indicating same thing. Both parameters are indicating the same thing. Fine. EC is equal to 1 and EM is equal to 0.5. We know that MS is equal to EM by EC. MS is equal to EM by EC. This is the modulation index formula. So EM is nothing but 0.5 and EC is 1. So after that, the M is 0.5. So the modulation index for the given problem is 0.5. The modulation index for the given problem is 0.5. Next, we're going to see about another problem. So in this problem is based upon the carrier power. How we going to calculate the carrier power? Carrier power. Okay. Let's read the question and then we should go for the solution part. First, we can read the question and then we should go for the solution part. When the modulation percentage is 70% and AM transmitter radiates 10 kilowatt power, how much of this carrier power? Sure, there are two powers are there. There are two powers are there. Total power and carrier power. Total power, carrier power. So the entire power is indicated using the total carrier power. So from that we want to measure the carrier power. Fine. How much of this is carrier power? Solution. PT is equal to 10 kilowatt. Okay. Total power of the modulated signal's total power is 10 kilowatt and M modulation is the 0.75. So with this modulation index we can get back the some values. We can get back the some values. The general formula of P total is 1 plus M square divided by 2 whole into PC, where M is the modulation index value. So 1 plus M square divided by 2 into PC. Okay. So therefore from this P to PT we can get back the PC value. We can get back the PC value. So therefore PC is equal to P total divided by 1 plus M square divided by 2. 1 plus M square divided by 2. Now we shall apply. We know the M square value. The M square value is given. The modulation percentage is there. So from that we can get back the modulation percentage is nothing but modulation index value. So we get back the M value from that. And P total value is given. The PT is equal to 10 kilowatts and AM radiates 10 kilowatt power. If AM transmitter radiates 10 kilowatt means it indicates the AM signal strength is power is 10 kilowatt. So P total is nothing but 10 kilowatt. And now from we want to measure the carrier power. We want to carry the carrier power. So 10 kilowatt, 10 into 10 to the power 3 divided by 1 plus, and instead of that for M square we should go for the modulation percentage of the modulation index, which is 0.75 the square divided by 2. Okay, I think everybody should have the calculator and we can get back the answer as the 7.8 to 10 to the power minus 3 into 10 to the power 3 watt. By something but the power signal used for carrier strength is 7.8 kilowatts. 7.8 kilowatts. Next we can see about another problem. Okay, in this problem, the things so here what we want to see the sideband component of AM wave. Sideband component of AM waves. Okay, we want to measure the least significant. Okay, LSB and LSB and USB. Okay, if we modulate the signal, there will be a central signal and there will be additional carrier signals in but FC plus FM and the FC minus FM. FC minus FM is known as the FLSB. FC plus FM is nothing but the USB. But a 500 watts, 100 kilo carrier signal is modulated. 500 watts and 100 kilohertz nothing but the indication of the carrier signal strength and frequency, and is modulated to depth of 60%. Modulation is given as the 60%. Very good. By the modulating frequency of 1 kilohertz. Fine. While the modulating frequency of the message signal is going to be 1 kilohertz, calculate the total power transmitted. Whereas we require the strength of the message signal is not directly given. It's indicated through the modulation index. So from the modulation index, we can get back the message signal strength. So here we want to calculate the sideband. Here the sideband is a very important parameter. So we want how we know to know how we are going to calculate the sideband of the signal solutions. Okay, now we can see get into the problems. Okay, now we get into the problem. So what are the things we're going to see? So what are the things first we want to write? What are the things we do have? We have the PC carrier power of the carrier signal 500 watts and frequency 100 kilohertz. And the modulation index is nothing but 60% is equal to 0.6, and the FM signal is 1 kilohertz and FM signal is 1 kilohertz. So message signal frequency is 1 kilohertz. And we know that PT, P total is equal to 1 plus MC M square divided by 2 into the PC. This is what the total power of what we want to calculate. In that, what we're going to calculate is we want to calculate the sideband allowance. We want to calculate the sideband allowance. So we can just calculate it. From the given formula, we shall calculate the P total, and then with the thing we can measure the FC and FUSB and FLSB. Fine, 590 watts. FUSB is nothing but FC plus FM, and FLSB is nothing but FC minus FM. FUSB is equal to 101 kilohertz, and FLSB is equal to LSB is 99 kilohertz. Fine. So next we're going to see about another problem. Next we're going to see about another problem. In this problem, what we're going to calculate? In this problem, we're going to calculate about the sideband frequency and the bandwidth, power in sidebands, and total power in modulated load. So these are things we're going to calculate it. So this problem is somewhat a huge problem. Here we're going to calculate the sideband frequency, which is LSB and USB. We want to calculate it, and bandwidth of the signal, and then it has the we want to calculate the sideband and total power in modulated signal. So from the questions, what are the things available? It's nothing but PC is equal to 400 watts and FC is equal to 1 megahertz, and modulation index is equal to 0.7, and modulation index is nothing but and modulation index is nothing but and modulation index is nothing but is going to be the thing we want to calculate it. It's nothing but 70%. It's nothing but 75%. And modulation index is nothing but 70%. And here we're going to see about FUSB is equal to FC plus FM, and FLSB is equal to FC minus FM, and the bandwidth formula is 2FM. So bandwidth is the subtraction of these two things. FUSB minus FLSB is the formula for bandwidth, and if you separate both the things, we will get 2FM. So bandwidth of the modulated signal is 2FM, right? And we want to calculate about the all the things. We want to calculate about the all the things. So from FUSB is given as the 1000 to 1002.5 kilohertz. Fine. FC is 1 kilohertz, and FM is 2.2 kilohertz. From this, by adding these two signals, FC and FM, we will get back the FUSB. By separating these two signals, we will get back the FLSB. Okay. With the help of FM, we can get back the bandwidth of the frequency, which is about 5 kilohertz, which is the 5 kilohertz. Right. Here we know that the formula for P total is equal to 1 plus M square divided by 2 into PC, and the total power. Now with these two factors, we can calculate the total power of the amplitude modulated signal. 1 plus 0.75 square divided by 2 into 400. Right. And therefore, from this, after calculating all this, the thing is that 512.5 watts. So this is the total power required to transmit an amplitude modulated signal, PUSB, and PUSB, and it is equal to PLSB. Fine. And then PUSB is equal to PLSB. From this we shall measure out the power consumed by the lower sideband and upper sideband. PUSB is nothing but upper sideband. PLSB is the lower sideband. Okay, and with this we can calculate the thing value. So it's nothing but 56.25 watts. 56.25 watts. Just see it over this. Now we're going to see another problem. With this problem, we're going to calculate the bandwidth, power in sideband, power is consumed by the sideband, and total power is required. Power of total. Okay, P total we're going to calculate. So we're going to calculate P total, we're going to calculate the bandwidth, and we're going to power the P USB upper sideband, P LSB lower sideband. PC is equal to 70 watts, FC is equal to 1 megahertz. From the gate questions we are taking these things. And modulation is nothing but 50%. Modulation is only 50%. Is equal to 0.5, which is equal to 0.5, and FM frequency, okay, frequency is 2 kilohertz. Frequency of message signal is 2 kilohertz. 2 kilohertz. We know that frequency of upper sideband and frequency of lower sideband, FC plus FM, FC plus FM, and FC minus FM. Upper sideband is FC plus FM, and lower sideband is FC minus FM. Upper sideband is equal to 1002 kilohertz, and lower sideband is going to be, from the formula we know the frequency of carrier frequency and frequency of measured signal. From this way, by adding the both the signal, we get the frequency of upper sideband, and separating both these frequency, we get the frequency of lower sideband, which is nothing but 980 kilohertz, and band is equal to FM FUSB minus FLSB. Frequency of upper sideband and frequency of lower sideband, which is equal to 4 kilohertz. And we know that total, okay, we know the formula for calculating the total power of AM transmitter is equal to P total is equal to 1 plus M square divided by 2 into the PC, where PC is the power required, power has been consumed by the carrier frequency. So P total, and we know the power of K. We know the PC value is 750 watts, which is given in the upper in the constraint itself. So we know the modulation index value is 0.5, and from that we can calculate the total power consumed by the AM modulated signal, which is nothing but 843.73 watts. 843.73 watts. Okay, and then the power of the, and now we want to calculate about the power for upper sideband and power of lower sideband. They both have the same formula. To calculating the power of USB and calculating the power of LSB has the same formula, which is nothing but M square divided by 4 into PC, where M is the modulation index. So we know the modulation index value is 0.5, 0.5 divided by 4 into PC. The PC value is nothing but we have 750 watts, 750 watts. So 0.5 divided by 5 into 4 and into 750, which is about 46.875 watts. 46.875 watts. So this is how we are going to calculate all the things in the single problem. Fine. Next, we get back in the next problem. Next, we're going to get back in this next problem. Calculating. Okay, in this problem, what we're going to calculate: how much power has been saved. How much power has been saved. So, power suppressed divided by power total will give the power saved. Power suppressed and power total is going to be this saved. So, what is the power saved is, man? While we're transmitting an AM signal, we have two sidebands. One is upper sideband and one is lower sideband. Either one sideband can be avoided, and we can by that also the signal quality will be saved. So by suppressing the thing, how much energy have been saved is going to be seen in this problem. Okay, calculate the percentage of power saving when one sideband and carrier is suppressed in AM signal with modulation index is equal to 1. Since the only one parameters we know is the modulation index value is going to be 1, and they calculate the percentage of power saving when one sideband and carrier is suppressed in AM signal. So M is equal to 1. So from this we know that we should calculate the total power. Total power is equal to 1 plus M square divided by 2 into PC, where M value is 1. So 3 by 2 into PC. So suppressed one is equal to PC plus PLSB, and we not use PUSB, only LSB. Fine. So therefore suppressed is equal to instead of PC plus M square divided by 4 into PC. Whereas suppressed PC is equal to formula PC plus 1 divided by 4 into PC is equal to 5 divided by 4 into 5 divided by 4 into PC. Amount of power saved is equal to P suppressed by P total. Amount of power saved is equal to P suppressed by P total. And the amount of power saved is equal to 5 divided by 4 into PC and 3 divided by 2 into PC, which is equal to 10 divided by 12. 10 divided by 12 is equal to 0.83. 83, which is about 83.3%. So totally we can save 83.3% of the total power consumed required for to transmit a AM signal by suppressing or avoiding one sideband and suppressing the carrier wave. Next we're going to see another problem. In this problem, in this problem also we're going to see about the same. Calculate the percentage of power saving when one sideband and the carrier is suppressed in AM signal. The percentage of modulation. Okay, just read out the question and just understand what they have been asking. Calculate the percentage of power saving. So we want to calculate the power saving where one sideband, either it may be an upper sideband or maybe a lower sideband. Generally, in AM signal, while we transmitting the energy, it consumes high energy. Why it's consuming high energy? Consider if a work should be done by a person, and that person is following the two person to support him. It means that only a one support is required. There are no need for two supports. Okay, so you can avoid any one person. So if one person avoided, the expenses and the resources required by a one person has been reduced, and only the same message is carried over very same two person. If you also combine a person with them, he thinks the same thing could be happen. So by removing the person, we can limit the resources. So this is what the pointers is going to be applied in the AM modulation signal. In AM modulation signal, we have a two sidebands, upper sideband FUSB and lower sideband FLSB. Upper sideband is nothing but the FC plus FM and lower sideband is nothing but the FC minus FM. So in either one sideband is required, probably most of them will go for the FLSB, which is the low frequency, which means we can go with the low energy. Low energy is required to generate this signal. So mostly we go for the FLSB. So that's only all the problems we will see. In previous problem also we have been seeing about PSP, LSB. All the problems deal with the PLSB. In this problem also we're going to deal with the PLSB and we're going to calculate the percentage and we're going to calculate the percentage of the sidebands. Fine. In this problem also calculate the percentage of power saving on one sideband and carry it suppressed in AM signal percentage of modulation. Modulation index is alone given is nothing but 50% is nothing but 0.5. M is equal to 0.5. We know that we know they've already we have been seeing many problems how to calculate the total power consumed. So total power consumed by the AM signal is nothing but 1 plus M square divided by 2 into PC. 1 plus M square divided by 2 into PC. And we know the point value of M square value is 0.5. So it's going to be 0.5 1 divided by 2. So that is 9, okay, 9 divided by 8 into 9 divided by 8 into 9 divided by 8 into PC. 9 divided by 8 into PC. So what is the power percentage? What is the power? How we calculate the suppressed power? P suppressed is equal to PC plus PLSB. So we want to calculate the suppressed power. So we want it's nothing but PC plus PLSB. So we want to know about the PC value and we should know about the PLSB value. By that alone, we can get back the P suppressed. So P suppressed is equal to PLSB value is nothing but okay M square divided by 4 into PC. M square divided by 4 into PC. Therefore, 1 divided by 16 into PC. PC plus 1 divided by 16 into PC, which is equal to 17 by 16 PC. So 17 by 16 into PC is the P suppressed power of suppressed one. So amount of power saved, amount of power saved. So how we calculate the amount of power saved? The amount of power saved is calculated by P suppressed divided by the P total. P suppressed divided by the P total. So these are the things we have been seeing. So from this, how amount of power saved is nothing but 9 divided by 8 into PC and divided by 70 into 16, 17 divided by 16 into PC, which is nothing but 9 into 16 and 8 into 17, which is nothing but 0.944, which is nothing but 94.4%. So total power saved is 94.4%. Only 5.6% is energy is used to transmit some signal. So we can once again get back to the problems. Once again get back to the problems. So in this problem, what we have seen, okay, once again get back to the same the basic problems. Okay. So this is the amplitude modulation of the signal. I carry frequency is very according to the instantaneous amplitude of the modulating message signal. And this is the formula for the carrier signal cos 2 pi fct plus cos 2 pi cos omega ct cos omega ct cos omega ct and modulated signal sin of t is equal to cos 2 pi fmtt and cos plus cos omega mt. Therefore, SAMT is equal to ACT is equal to AC plus MT into cos 2 pi FCT, cos 2 pi FCT. So what we see in the problem, that so far we have seen some problems. Okay, in the problem what we have seen, is that we have seen in this first problem, we have seen how to calculate the modulation index. Modulation index is main parameter, and this how we this thing how we calculated the modulation index has been seen over. We have been seen over. Okay, the modulation index is nothing but the it's a difference between EM by EC. EM is equal to 0.5 divided by 1, so it is by 0.5. Next problem, we have divided and we have calculated the carrier power, and we have calculated the carrier power PC. PC from the total power. Total power is the total power consumed by the AM signal to transmit the AM signal. So AM signals P total is equal to 1 plus M square divided by 2 into PC. Fine. PC is equal to P total divided by 1 plus M square divided by 2. Where PC is equal to 10 into 10 to the power 3, 1 plus 0.75 into whole square divided by 2, where PC is equal to 7.8 into 10 to the power 3 watts. From that, PC is equal to 7.8 kilowatts. Right. And the next once again, third problem what we have seen. What we have seen is that A is equal to 500 watts and its frequency is 100 kilohertz. Carrier is modulated to the depth of 60%, where the depth of modulation is nothing but modulation index by the modulating frequency. But modulated frequency is nothing but the message signal of 1 kilohertz. Calculate the total power transmitted. What are the sidebands components of the AM signal? Solution PC is equal to 500 watts and FC is equal to 100 kilohertz and M is equal to 60% is point. And FM is equal to 1 kilohertz and FM is equal to 1 kilohertz. We know that P total is equal to 1 plus M square divided by 2 into PC. 1 plus M square divided by 2 into PC. Where P total is equal to 1 plus 0.6 the whole square into divided by 2 into 500. From this we can calculate total power starting by 590 watts. And here we can discuss about the upper segment, lower segment. Upper segment is indicated by the USB. Upper segment and lower segment is indicated by FLSB, FC minus FM, FC plus FM, which is equal to 101 kilohertz and which is 99 kilohertz. Problem. Here we in this problem also we are seeing about how to calculate the power consumed by the lower segment, upper segment, and both are the same. In this problem, which deals in this problem, they are given the carrier power 400 to 400 watts and the carrier frequency 1 megahertz and the modulation index and the frequency of the message signal. So with this parameter, we should calculate the total power of the modulated signal, total power of the modulated signal. From this way, okay, from this USB, FC plus FM and LSB, FC minus FM and bandwidth is 2 FM. So from this we have been calculated the all the frequency. This is nothing but 102 kilohertz and 9.75 kilohertz and 2 into 2 kilohertz and 5 kilohertz, and we know that P total is equal to 1 plus M square divided by 2 into PC, and P total is equal to 1 plus 0.75 the whole square into 2 into 400. P total is equal to 12.5 watts, 12.5 watts. So therefore, PUSB and PLSB is equal to M squared divided by 4 into PC, where nothing but the power of the both the upper sideband and lower sideband is equal to 0.75 or 0.75 squared divided by 4 into 400, which is nothing but 56.25 watts. So in the first problem, what we have seen, a carrier of 750 watts of 1 megahertz is amplitude modulated by the sinusoidal of signal of 2 kilohertz to a depth of 50%. Calculate the bandwidth of the bandwidth power in sideband and total power is transmitted. Solution. So therefore the carrier power is equal to 750 watts and FC. Carrier frequency of 1 megahertz and M is equal to 50%, which is equal to 0.5, and FM is equal to 2 kilohertz, and therefore the FUSB is equal to FC plus FM, the FFL is equal to FC minus FM. So FUSB is equal to 1002 kilohertz and FLSB is equal to 8 kilohertz, and bandwidth is equal to FUSB minus FLSB is equal to 4 kilohertz. When we know the formula for the total power consumed, from that we can calculate the total power consumed is nothing but 843.75 watts. So from this total power consumed, we can calculate the we know the formula for the calculation of the power of upper sideband and lower sideband is nothing but M squared divided by 4 into PC. So from this, the power consumed by the upper sideband and lower sidebands we have been calculated 46.875 watts. 46.875 watts. In this problem, what we have been seeing, we have been calculating the total amount of both the problem 6 and 7 problem always deals with the power has been how much power has been saved. The power saved is formula is deals with the P suppressed by total power. P suppressed by the total power. So here we want to calculate the total power. You know the total power formula is 1 plus M squared divided by 2 into PC. This is number 3 divided by PC. And we know the P suppressed formula PC plus LSB. So we just calculate the PCB LSB. all the terms will be in terms of PC, and we don't have the PC. From this, the PC is the common term. By taking the PC as a common term, we can avoid the PC, and from that, we're going to get the percentage of the power consumed, which is nothing but 0.833. 0.833 is equal to 83.3 percentage. So 83.3 percentage of the power has been saved in the given problem. And here, next problem, the last problem that we have seen is here we want to calculate the total power saved. The total power saved formula has been already seen. The total power saved has been P surplus divided by the P total. So here we want to P total and we want P surplus. What are the factors given is only the modulation index, which is the 0.5. So with this formula, we're going to calculate the total power consumed in terms of PC. In terms of PC, is nothing but the PC divided by PC plus 1 divided by total power is nothing but 9 by 8 PC. 9 by 8, finally we calculate 9 by 8 PC with the help of the modulation index. We calculate in terms of PC. And the P suppressed formula is PC plus LSB. PC plus LSB formula is 1 by 16 into PC, which is number 17 by 16 PC. So we want to divide this 17 by 16 PC divided by 9 by 8 PC. So PC get cancelled, and finally 9 into 16 and 8 into 17 is by combined. So therefore 0.944. This is nothing but a figure, and we want to convert the percentage. We want to convert plus into multiply into the 100. So 94.4% of the power has been saved. So in this, so far we have seen about amplitude modulation, how the amplitude modulations happen, what is the purpose of amplitude modulations happen, and the advantage of the amplitude modulation has been seen. So what are the here we see the problems, how the modulation index, we have seen the modulation index percentage, and we have seen how to calculate the power consumed by the total AM signal, and how much power has been consumed, and how much power can be saved. All the things have been seen in the problem, and you can note over the problems also. So finally, we have been seeing completely all the type of the things in the AM signal. So thank you for watching the session.